Hello, welcome to our penumbral lunar eclipse live stream. My name is Haley Osborne. I'm one of the educators here at Lowell Observatory. And right now, what you're looking at is actually a live stream of the moonrise over Flagstaff. So if you look there, you can see the town, and off to the right, the moon is rising. So we'll periodically be moving back and forth between this view and a couple of other things that we'll be looking at tonight. But first, let's talk about why you guys are all here. So if you want to go ahead and pull up our presentation we've got going on, we will take a look at what a penumbral lunar eclipse is. So there are three main types of eclipses. See, you can see here we have a total lunar eclipse, a partial lunar eclipse, and a penumbral lunar eclipse. Now, down there at the bottom, you can see pictures of what each one of these guys looks like. The one on the far right is what we're going to be seeing tonight. So a penumbral lunar eclipse is not as noticeable as the other two types of eclipses that we can see there, but it is quite easy to view even with just your naked eye or a pair of binoculars. But what really is a penumbral lunar eclipse? Well, if we move on to the next slide, you can see that there's a diagram right here of what this is going to look like from outer space. So on the very left there, we can see the sun, and the sun is shining some light onto the earth. And then we can see two shadows, a very dark one and a lighter one. So this setup right here is what a penumbral lunar eclipse looks like. A total lunar eclipse would be where the moon is inside of the umbra. That's the darker part of that shadow there. A partial lunar eclipse would be where the moon is inside of the penumbra. And as you can see here, the penumbral lunar eclipse, we have the moon only partially in that penumbra. So the moon is going to be about 33% darker than it normally is. Now, how do we view a penumbral lunar eclipse? Well, if we look at our next slide we've got there, you can see that it is quite easy to view a penumbral lunar eclipse. All you really need is a nice clear sky. You want to dress for the weather. Here in Flagstaff, it does tend to get a little cold at night. You want to find a comfy chair and know what to look for. So personally, if I were you guys, I would find a nice comfy camping chair, go sit outside on a porch or out in the forest with a blanket, maybe a cup of cocoa, right? And look up at that night sky. Now, if we want to move back to the moon cam, we're going to see the penumbral lunar eclipse starting at about 8:07. So currently it is 8:03 here in Flagstaff, Arizona. So it's going to be just a couple more minutes before the eclipse starts. Now, the height of the eclipse, the maximum, is going to happen at about 9:30 p.m. here in Flagstaff, Arizona. So make sure to check out your local time when that will be. And then the eclipse will end at about 10:52 p.m. here in Flagstaff. Now, if we want to go ahead and talk about the telescopes that we're going to be looking through on the Giovanni Open Deck Observatory, we've got some slides on that. Now, there are a couple of different telescopes up on the Godo, the Giovanni Open Deck Observatory. We're actually only going to be using one of them, but let's go ahead and talk about all of them first. So if we want to pull up the slides on our Godo telescope, so you can see this really beautiful image of the Open Deck Observatory. Now, the first telescope we're going to talk about is going to be, I believe, our Tech telescope. If you want to go to the next slide, Danielle. Oh, my bad. It's the Meade telescope. So this is our 16-inch reflecting telescope. So if you're a telescope geek like I am, we've got a bunch of the specs on our Meade telescope off to the right there. And these telescopes were all donated, all of the funds were donated by our generous donors here at Lowell Observatory. So we like to give them their thanks and credit. Now, can we go to the next telescope? We have our the next telescope, the next slide, we have our Tech telescope. So the Tech telescope is a refracting telescope. Now, the difference between a refracting telescope and a reflecting telescope is what's being used inside of them. So, a reflecting telescope uses mirrors that bounce the light back and forth out into the eyepiece, either at the bottom of the telescope or the side of the telescope. But refractors, like the Tech here, they use lenses that bend the light into a single point. So the Tech is a 5.5-inch telescope, and you can see that it's not very long, but it is quite a bit longer than a 5-inch reflecting telescope would be. And again, we have the specs off to the right-hand side. Now, if we want to move on to the next telescope we've got, that is our 8-inch Moonraker Victorian refractor. So the Moonraker is a pretty fantastic instrument. We built this to kind of look like the Clark telescope, right? This was kind of an homage to the Clark telescope. And even though it's only an 8-inch telescope, this refractor is about 8 feet long. So that's what I mean when I'm talking about how lenses make telescopes a lot longer than they should be, right? All of that light is bending into a single point, and it takes about 8 feet for that to happen. And this one as well has the specs off to the right for you guys. All right. I am getting a message here. So there are some clouds on top of the moon. That is not the eclipse yet. So just keep that in mind. There are a couple of sparse clouds up here in Flagstaff right now. So we might be getting some of those in and out over the moon. Like I said, the actual eclipse starts at 8:07. Now, the next telescope we're going to talk about is our 32-inch star structure Dobsonian reflector. So this telescope has a base mirror that's 32 inches, and it collects a lot of light, brings it up to a secondary and out the side for you to view. This is the largest telescope here on our Mars Hill campus, and if I do say so myself, it's got some of the best optics I've ever seen. So if we want to move over to our live stream, first contact of the penumbral lunar eclipse is happening right now. So we can see it is quite beautiful, right? We have a little bit of cloud coverage over the middle there, but it is still showing that little partial lunar eclipse. Now, if we want to move back, let's talk about the last couple of telescopes really quick. So that was the 32-inch star structure we talked about. We want to move on over to the next slide. We're going to see our 17-inch plane wave corrected Dolly-Kirkham reflector. This is going to be the telescope that we'll be using tonight to do most of our viewing other than the live moon cam. But we are going to be using this to move around and view different objects. And as you can see, the specs are on the side right there. Now, there is a difference in what I have on this slide and what's actually going to happen. So on this slide, it says that our instrument is a spectroscope. Now, there is a spectroscope on the back of our 17-inch telescope, but we're actually going to be using the Malincam instrument. So if we go to the next slide, we've got our 14-inch plane wave. Now, the 14-inch is the one that normally houses the Malincam camera, but it is unfortunately having some technical difficulties. So we have actually moved that instrument over to the 17-inch plane wave, and that's where we're going to be doing all of our viewing. So if you guys are ready like I am, let's go ahead and look at the Malincam now. So right now we have a live feed happening from up here on Mars Hill campus of, we're going to be looking at right now a binary star system called Albireo. Now, Albireo, binary star system, is two stars that are in the same system, right? So we would think of it as the same solar system. Now, two stars orbiting around one another, that's a binary. That's what you're seeing right here. The one to the top right, or the top left in this image right here, this guy is a redder star. So this is going to be an older, colder star. And the bottom right is going to be a bluer star, which is a much hotter, younger star. Now, before I get too into binaries, I would like to tell you guys that the eclipse does take a while. Like I said, the maximum isn't until about 9:30, so we'll be checking back in periodically. And in between, we'll be taking some looks at the sky. And you guys are more than welcome to send some requests in our chat. We'll try to hit as many of them as we can. Some things, unfortunately, aren't in our night sky right now, but we'll let you know if they are up. And if they are, we'll take a look at those objects for you. Now, back to binaries. So a binary star system, when two stars are orbiting around one another, sometimes they'll get really close and they'll actually crash into one another. Now, when this happens, it creates something called a type 1a supernova. Now, a type 1a supernova is a pretty interesting phenomenon. So, supernovae, they are some of the most violent occurrences out in space, extremely bright. In fact, later on tonight, hopefully, we'll be able to take a look at M85, a galaxy that currently has a supernova inside of it, so we can actually see just how bright these phenomenon are. Now, a type 1a supernova is a special type of supernova because these supernovae, they don't have hydrogen lines in their spectra. So, what is a spectra? Well, this is something called spectroscopy. Now, spectroscopy is the study of light, how it interacts with things, and how it tells us things are moving. So, if you want to take something's spectrum, and we have a spectra all lined up for you, if you want to put that on up there, perfect, beautiful. So, on the left, we have our raw spectra, and on the right, we have it graphed out all nice and pretty for you. Now, a spectrum is basically this big bar, right, with dark lines inside of it that tell us what things are made of. These type 1a supernovae, they don't have a hydrogen line. And if you look to the far right of the colorful picture, that first divot right there, that's one of the hydrogen lines in, looks like this right here is the moon spectrum, right? Now, the moon spectrum we'll talk about in just a second, but in general, spectroscopy is telling you what things are made of. And so these type 1a supernovae, they don't have a hydrogen line, right? They don't have this hydrogen line, but they do have a very strong silica line. So this makes them very noticeable, very distinct from other supernovae. Now, astronomers, they know the absolute magnitude of type 1a supernova. And so we can actually use these to figure out distances in space. I've heard them talked about as like candles in the dark, right, leading us to how far away things are. And so we can tell by these type 1a supernovae in different galaxies how far away that galaxy actually is. So not only are type 1a supernovae extremely important and very useful in astronomy, but spectroscopy itself is also extremely important and really useful in not just astronomy, but in pretty much every field of study, every STEM field of study. Now, what we're seeing right here is the moon spectrum. And what's really cool about the moon spectrum is that it is almost identical to the sun spectrum. So you can see right here, this is our sun spectrum. Now, I want you guys to sit and think about for a second why this might be, right? Why are they so similar? Do you guys have it in your head? So it's because the moon is just reflecting sunlight. And so that's why these two spectrums are the same or very similar, is because they are showing the exact same light. Now, this leads me to a topic that is near and dear to my heart. Are there any people out there who are fans of folklore? Because one of my favorite things to talk about when I get to this point, when I talk about spectroscopy and the sun and the moon, is vampires. Now, I know that sounds weird. What do vampires have to do with astronomy? But just hang in, bear with me. Vampires and astronomy. The reason I bring this up is because vampires in folklore, most of the time, if they go out in the sunlight, they burst into flames, right? They're not allowed to go out during the day, but they're totally fine going out at night, which doesn't make sense to me because the moon is just reflecting sunlight. So if the moon is reflecting sunlight, shouldn't vampires burn up once they're touched by the moonlight? I mean, I think that's a flaw in folklore. And I actually this was just brought up by one of my coworkers, but this also has to do with werewolves, right? Because werewolves, they transition during the full moon. But I mean, if that's just reflected sunlight, does that mean that werewolves should change every single day when the sun rises? So those are some fun things I like to talk about. But anyway, that's just me. Now, if we want to go ahead, and are there any other binaries that anyone would like to look at? Do we have any requests in the chat for that kind of stuff? Oh, so we've got Algeba. All right, so let's go ahead and look at Algeba, another really awesome binary star. And Algeba, I believe its technical name is Gamma Leonis, which I think is a really pretty name. But Algeba just sounds kind of quirky and funny, so I really like this star system because it's kind of got both sides there. Now, on the Cam, if you see what Sarah just did, she moved over the exposure time, right? So you can see her mouse moving around. The exposure time is how long we take in light for. Now, when it comes to stars, really bright objects like that, we're not going to want to take in very much light. But as the night progresses and we start to look at deeper space objects that are much fainter, we'll start needing to up that exposure time. And so down at the bottom, you can see we've got video mode and trigger mode. So video mode is what we're on right now, and trigger mode is what we're going to need to be on when it comes to things like galaxies and nebulae that we'll hopefully be able to see later on tonight. Now, if you notice, these two stars, they're extremely close to one another. In fact, they're shimmering so much that it might even look like they might just be one star. Now, that shimmer, it actually has to do with Earth's atmosphere. Now, Earth's atmosphere, it is not as thick up here on Mars Hill, because the higher up in elevation you go, the less atmosphere there is, which is awesome because this right here, this wobbling we're seeing, is atmospheric disturbance. So if you have ever felt the wind or breeze in your hair, which I'm hoping that every single person has, but if you feel that, that's what you're seeing right here, right? This light from these stars are coming in as single points. It's hitting the particles in the air, and it's starting to refract all over the place, right? It's throwing all of this light all over the place. And the cool thing about Algeba here is you can actually see there's some colors on there, right? Some color disturbances. With my eyes, I'm seeing a little bit more blue towards the bottom and kind of like pinks on the side as well. So I think that's pretty fantastic. Now, before we get into more stargazing, let's go ahead and go back to our moon feed. So we've got our moon cam going nice and strong, and we can see there is a little bit of a shadow there, right? So for those of you guys who are just joining us, we are, of course, looking at the penumbral lunar eclipse. And the penumbral lunar eclipse is when the outer part of the Earth's shadow passes over the face of the moon. This event began at 8:07, and it will peak at 9:30, and it will end at about 10:57. So we'll be continuing to go back and forth between our stargazing and our moon feed. And so it looks like, oh, so the shadow we're seeing right now actually isn't from the penumbral lunar eclipse right now. The moon is a little bit behind a tree. So we're seeing a little bit of interference there, but the shadow will appear on the upper left edge when it shows up. So keep an eye on that while we're going periodically back and forth between our moon cam. So, oh, sorry about that, guys. The moon is in a tree with our Cam software, but we're gonna go ahead and try to see it anyway. So let's go ahead and move over there. So this will be a much closer up view of the moon, and you'll notice that we're keeping the exposure time very low because the moon is extremely bright. Oh, if you guys saw that, let's zoom on out and see if we can find it. Oh, there we go. That's a really nice, beautiful view of the moon. Yeah, so even in a tree, Cam is doing pretty great. We will be able to see more once the moon is out of the tree. That's what the dark shadows are that you're seeing on there. That's the tree, and you can see that it's kind of blowing out the bottom left corner. Right, it's a lot brighter. And so if we turn down the exposure time, that part that's lit up right now, that's what the moon actually looks like. The part that's darker is the part of the moon that's in the tree. So once the moon passes out of that tree, we'll come back to it and take a look. But since we are in a tree right now, and since the night sky isn't quite dark enough yet to see some really awesome deep space objects, let's go ahead and take a look at the lunar maps. Now, the lunar maps that we have right here, they are near and dear to Lowell Observatory's heart. And that is because Lowell Observatory was one of the main places where the the Aeronautical Charting and Information Center did their lunar mappings back in the 60s for the Apollo missions. So you can see here, there's quite a bit of detail in these maps right here. Now, the crazy thing about this is these were actually done by hand. So a lot of people would think, well, why don't you just take a picture of the moon? Because we did have that kind of technology, right? We had the technology to take these pictures. But the issue is to take a long exposure photo. That means that that atmospheric disturbance that we were seeing with the stars that we were showing, it'll distort the image, right? It'll fuzz it out a little bit. You won't be able to see anything as clearly. And so that's where the human eye comes in. The human eye only takes in fractions of seconds worth of light at a time. And so if you're looking at the moon right here like it is, you can see it wobbling a little bit, but your eye, it corrects for that over and over again because you're taking in so many exposures in fractions of seconds, which is why these maps that we're seeing here were done by hand. It was actually Patricia Bridges was the main cartographer on the mission, and Bob Malfair was the guy who operated the astrograph. The astrograph is the telescope that took the pictures. And this right here is a map that they made of the Apollo 11 landing site. So this is the Sea of Tranquility. And Sarah can show you with her mouse there about where it happened, right about where the landing took place. And now, the reason that they chose the Sea of Tranquility instead of somewhere else on the moon to land actually has to do with the topography of the moon, right? The surface of it. So, oh, that's much better. That was a really great view. So you can see here that there's a lot of spots all over the moon, and a lot of those are craters, which you can see a lot better on our map there, right? So these craters, they have a lot of stuff going on around them. There's a lot of hills, there's a lot of valleys, and so we had to choose very specific spots for where we wanted to land our Apollo missions, because you need to land somewhere that's flat, right? You want to land somewhere that's not super rocky and where you won't end up in a giant hole, because it takes a lot more effort to move on the moon than it does to move around here on Earth. And so trying to get out of a crater on the moon would take significantly more effort than it would to get out of a crater, say, here on Earth, right? Because there are craters all over Earth. There's two really close to Flagstaff, actually, which, fun fact, the Apollo 11 astronauts, the Nifty Nine, they actually came here to Flagstaff to train, and they went to Sunset Crater and Meteor Crater to do a lot of their training. So Flagstaff's lunar legacy is pretty significant, right? Not only did Lowell Observatory host the ACIT, oh, sorry, I'm being corrected. It's the next nine, but the next nine astronauts, they were the ones who came here to Flagstaff. But not only did Lowell Observatory host the Aeronautical Charting and Information Center, but we also had all of the astronauts come out here, look through a couple of the telescopes here in Flagstaff, go out to the different sites and test all of their lunar crafts that they had put together. Now, you can see here the moon is pretty much almost completely out of the tree on the Malin cam. So we've got a really nice view. We've got some darker spots, some lighter areas, and these all have names, right? They all have specific names for the specific different things that are on the moon, but there's also kind of blanket terms, right? So those darker spots there, we call those Maria, which is Latin for sea, because when people looked up at the moon, they saw these darker spots and they thought that they might be oceans. So what's actually happening here is the moon, when it was first formed, was actually volcanically active. It had a molten iron core, and it was spitting out a bunch of volcanoes. And so what you're seeing here, this is actually basaltic lava rock from those lava flows. And that basaltic lava rock is almost identical to the stuff we find here in Flagstaff. So that's the fun little fact about it leads us actually into the formation of the moon, right? Because we believe that the moon was actually a big chunk of stuff that was attached to proto-Earth, right? So proto-Earth, that was before the Earth. So it was this big, huge chunk of metal and of debris. And a big piece of debris came throughout the solar system, hit that big chunk, and knocked a smaller chunk off of it. And then everything started to cool down, it started to settle, and then we ended up with the Earth and the moon. And so it makes sense that the samples we took of the moon are very similar to stuff that we would find here on Earth. So those Maria, like I said, those are basaltic lava rock areas. Now, the really bright parts of the moon are called highlands. Highlands are actually the oldest parts of the moon, and you can see really nice in this picture right here, all of those little pock marks of all of the really bright highlands on there, in great contrast with the Maria. And then, of course, there are some kind of medium colored areas. A lot of those are impact craters because the moon does get hit with quite a bit of stuff over time. And some of those, oh, yes, yes, bring up the Sea of Tranquility blue picture. So this is a really cool picture. First off, because I mean, astronauts in space. But second is it's actually showing you that the Sea of Tranquility isn't as white as the other areas that we were seeing on the moon. It's also not as dark as the other areas we're seeing on the moon. It's almost a blue color. And we think that that's telling us that the Sea of Tranquility actually has a higher metal content in it. And so it's showing off a little bit of this bluer tint. Now, if we go back to our live feed, you can see that the Sea of Tranquility, you can't really see that bluer color unless you're right up next to it. So we've got our little, another little pad showing us. So right in there, that's the Sea of Tranquility area. And so you can't really see the bluer color unless you're right up next to it. But yeah, so now if someone ever asks you what color the moon is, you can say blue and you're not technically wrong. So definitely don't do that though. People will think you're weird. Anyway, let's go ahead and look at that moon cam view we've got up. So our moon cam is actually set up here on Mars Hill over by our historic Clark telescope. It is overlooking the city of Flagstaff. So if we go up to, let's go to kind of a wider field view that we've got going on here. Right, so you can see the moon very bright, very beautiful. We can't quite see the shadow coming in yet, but it will happen soon, right? This is a very long process that we're going through. If you want to zoom, yeah, there you go. That's a beautiful image. So you can see the downtown lights of Flagstaff, nice and clear. You can also see that there's not a whole lot of light shining off from Flagstaff, right? And that's called light pollution. Now, there's not a lot of light pollution here in Flagstaff because we actually have a lot of ordinances put into place of what kind of lights can and can't be put up around people's houses, on in parking lots, all kinds of stuff. And that's because Flagstaff is an international dark sky city. We're actually the first international dark sky city. And the reason is because we like astronomy, right? We like astronomy a lot. I mean, Lowell Observatory has been here longer than Arizona has been a state. And so we wanted to preserve as much of the night sky as we could. And so we put in all of these ordinances. So even though we're right next to downtown here at Mars Hill, we still get beautiful views of the night sky. So let's go ahead and go back to our Malincam feed. And Sarah, do you want to move it over to Arcturus? Let's take a look at Arcturus. So Arcturus is one of the brightest stars in the night sky. It is the brightest star in the constellation of Boötes, and it is a nice bright red star. So if we bring it in here, let's up the exposure time a little bit so we can get some of that color in. There we go. Yeah, beautiful. You can see the red tinge around it. So Arcturus is what's called a red giant star. Now, a red giant star is the end of a smaller star's life cycle, or not quite the end, but almost there. And this is actually what's going to happen to our sun. Arcturus began its lifetime about the same size as our sun. But what happens with stars is they're fueled by hydrogen at their core. and eventually they run out of hydrogen. And when that happens, their core cools down and their outer gases expand. And so Arcturus, it began about the size of our own sun, but now it's about 30 times the sun's diameter. So it's gotten quite a bit bigger. And then when smaller stars die, right, stars don't end their lives the same way as we do, right? They get bigger and bigger, and eventually they'll push out all of their outer gases, and then they'll form something called a planetary nebula. Now, a planetary nebula is one of the worst named things in astronomy. It has nothing to do with planets, right? But they're beautiful nevertheless. Let's go ahead and try to move to one of the more well-known of the planetary nebulae, the Ring Nebula. And so we can see when we move over to a ring nebula what I'm really talking about. But basically, this star, its core cools down, outer gases expand. It pushes out all of those outer gases while simultaneously crunching in all of the inner gases. And you guys can see over to the left, Sarah switched over from video mode to trigger mode. Shout out to Sarah, our Malincam operator. Wave hi, Sarah, with your little, your little cursor. Oh my goodness. All right, yeah, so this is the Ring Nebula. Now, it is still quite bright outside. It will still be pretty bright for the rest of the night because it is a full moon, which is why you guys are all here. But we can see that nice little ring there. Yeah, and if you white balance color correct, right now we're seeing true color. So it got a little bit darker, as you can see there. Now, you can actually see some colors on the sky, which is pretty fantastic. We've got some reds on the outside, yellows towards the middle, greens and blues towards the center. And then at the very center, there's a little point there. And that little point is called a white dwarf star. Now, a white dwarf star, when we were talking about how stars end their lives, right? They push out, they push in. When they crunch in, that inner part is called a white dwarf star. That white dwarf star lets off a bunch of ultraviolet radiation and lights up all of the gases around it. Those gases are different gases that that star formed during its lifetime. Now, I just want to remind you guys, if you have any requests for what we can look at, it's getting dark enough to where we can start taking some of those requests. So just put them in the chat and they'll be fed over to us so that we can move the telescope around and see some really cool stuff. But yeah, that is the Ring Nebula. Now, this is the end of a small star's life cycle, like I said, and so this is actually what's going to happen to our sun in about, 10 minutes. No, I'm just kidding. It's going to happen in a couple billion years. So we've got plenty of time to figure everything out. All right, so let's see if we can see another planetary nebula. How about Dumbbell? Do you think it's dark enough for Dumbbell? This one's a little bit fainter than the Ring Nebula is, so hopefully we'll be able to see it. Fingers crossed. It's a really cool one. It's called the Dumbbell Nebula because, you guessed it, it looks kind of like a dumbbell. Personally, I think it should be called either the Bow Tie Nebula or the Apple Core Nebula because that sounds little bit cooler to me. So let's go ahead and try to maybe up the exposure a little bit. That might help. White balance, yeah. So the white balance is we put a little box in the image frame and we tell that image, okay, everything in this box should either be black or white. And then it color corrects so that we don't get any false color in the image that we're trying to show you guys. So as you can see over to the left, we have our color adjustments. There's hue, saturation, brightness, contrast, and gamma. Now, we don't normally move around the hue because that's what gives images false color. And we don't want to show you guys something that's not true. But the saturation, we use that a lot when we're talking about nebulae because it'll actually bring out the colors in the nebula more so that you can really see it. And it looks like I've got a request for the Lagoon Nebula. It is still a little bit too bright for that object, but we will keep that in mind. That is an object that I did want to look at later tonight. So we'll definitely check that out. So it looks like it's still too bright for Dumbbell. You can kind of see it in there, not quite. So unfortunately, we're going to have to come back to that object, one of my favorite things to look at. But let's go ahead and go back to our moon cam. So let's see if we can see a little bit of that shadow. And just a note, we are only 45 minutes past sunset, so it is still quite bright in the night sky. We're trying to get it a little bit darker, a little bit later, and that's it's getting it's getting darker earlier now that we've hit the summer solstice. Everything starts to go backwards, right? So the days are getting shorter and shorter, which is nice for us here in Arizona because it gets really hot during the day. So I'm excited for it to be fall and winter, be um, a little bit darker. So it looks like on our moon cam, there's still no discernible shadow, but that's to be expected. Like I said, the peak isn't for another hour, so we've still got quite a bit of time to be able to see that. Now, if you look over at the Malin cam, we actually have a really nice up close view of the moon in quite a bit of grayscale, right? So you can see the grays, we can see the darker spots, the whiter spots. Over to the bottom right, you can see some of the brighter craters on the moon, and it actually looks like, I believe, correct me if I'm wrong, but I think that brightest one in the bottom right corner, kind of a little bit higher, right about here. Yeah, that guy, I'm pretty sure is Tycho crater. Tycho crater is a lunar impact crater, and it's actually one of the brightest craters on the moon. Um, so that brightest crater there is actually relatively young, and the floor, it suggests that this was created after the moon was volcanically active, right? So the moon started its core started to cool down, and it was no longer volcanically active. Now, since we're talking about the moon, for those of you guys who are just joining us, let's go ahead and go back to our PowerPoint slide about the eclipse so that we can take a look at what we're trying to find. So here we've got our types of lunar eclipses, right? We've got total lunar eclipse, partial lunar eclipse, and penumbral lunar eclipse. So the penumbral lunar eclipse, that is the one that we are viewing tonight. And as you can see in the pictures down here, a lot of people, when they think of lunar eclipse, their mind immediately goes to the one on the left, right? The redder eclipse. And that would be a total lunar eclipse. And a total lunar eclipse is they actually happen about 35% of the time, right? Out of the three different types of eclipses, total eclipses are about 35% of those eclipses. Penumbral lunar eclipses make up about 33% of lunar eclipses. So we are viewing something that's actually a little rarer than a total lunar eclipse, but these do happen quite often. And if we go I got those mixed up. My bad. Total lunar eclipses are 35%. Penumbral are also 35%. Now, if we go to our next slide here, we've got our diagram of what a penumbral lunar eclipse looks like. So off there to the left, we've got our sun shining light onto the earth. We can see those two different cones, right? Those two different shadows. That middle darker part is the umbra. And when the moon passes into the umbra, that would be considered a total lunar eclipse. When it passes through most of the penumbra, right, that lighter area right there, that would be a partial lunar eclipse. And then as you can see right here, the moon is just slightly passing through that penumbra, and that's what a penumbral lunar eclipse looks like. So if we want to look at how to view a penumbral lunar eclipse, like we said at the beginning here, you just find a clear view of the moon and sky, right? The best views of the night sky, you would want to go outside of town where light pollution is very low. We talked about that earlier, how even up here on Mars Hill, the light pollution is pretty low because Flagstaff is pretty awesome about their light ordinances. You want to dress for the weather, even though it is summer here in Flagstaff, it does get kind of cold at night. Most of that is due to the fact that we don't have a lot of atmosphere trapping in heat. You want to find a comfy chair. So it doesn't necessarily have to be a chair. You could set up a hammock in the woods and you could just lay down, look up at the night sky, wait for that penumbral lunar eclipse to happen. That would be my favorite, honestly, and just know what to look for. So remember our slides about the fact that we're looking for just a slight shadow across the moon. Now, if we want to go back to our Malincam live feed, let's take a look at a new object. So this new object we're going to look at is called M13. M13. And it looks like Andrew requested this, Andrew M. We're going to look at the Hercules cluster, M13. So M13 is a globular star cluster. Now, a globular star cluster is one of many types of star clusters, and this one is very condensed and filled with a lot of stars. M13 itself is home to a couple 100,000 stars, and it is somewhere around 20,000 light years away at the outer edge of our galaxy, but it is still in our galaxy. It's not in some other galaxy, and oh wow, that's a beautiful view. Oh, sorry, I was that took my breath away. So with that white balance, you can see that these went from being very blue tinted to actually being red tinted. And that is true color, right? In these globular star clusters, the stars are typically redder. And that is because in astronomy, red means cold and blue means hot. Red means old and blue means young. These guys here are some of the oldest stars in our galaxy. And we actually think that these came from other galaxies that the Milky Way consumed. Now, this happens quite often. Two galaxies collide, and the scientific term for that is galactic cannibalism. That is a true scientific term, galactic cannibalism, when one galaxy eats another one. So this right here, this was possibly the core of a galaxy that the Milky Way consumed, comprised of hundreds of thousands of stars. If I remember correctly, I believe M13 is approximately 500,000 stars. So that's quite a bit, which is why we're seeing it so bright here. So it looks like oh, we can move. Oh, okay. So we're going to move over to my favorite galaxy. It's called M87. And M87 is not, it's not spectacular in the sense that you're going to see beautiful dust lanes or spirals or anything like that. It's spectacular because of what scientists have seen about it, what scientists have actually studied with this galaxy. Now, before I talk about that, let's talk about what's going to happen with our image here. You can see it is that fuzzy little haze in there. We might even want to up the exposure a little bit so we get a little bit more light, right? Because this is a dimmer object, because it is a deeper space object. This galaxy is about 50 million light years away. Now, the reason this is my favorite galaxy is because of a picture that came out last year. In my opinion, the best picture I've ever seen in my life, this one right here. So this picture is of a black hole. Now, I have a reputation here at Lowell Observatory. I am obsessed with black holes. So I love talking about them to anyone and everyone who will listen to me. So this one right here is something called a supermassive black hole. Now, what is a supermassive black hole? Other than a fantastic song by Muse, it is the exact same thing as a regular black hole, right? So a regular black hole would be this infinitesimal point out in space with pretty much infinite gravity and density, right? It's a very, very hefty, very small piece of something out there in space. This giant tunnel leading down to it, that little piece of something is called a singularity. And let's take a step back. Let me properly explain this to you. Let's imagine that you are holding up a blanket and I place a bowling ball in the middle of that blanket. It'll create a divot, correct? And then if I toss a ping pong ball onto that blanket, it'll start going around that divot. And that is how our solar system works. So in this case, the bowling ball would be our sun, the ping pong ball would be Earth, that divot is gravity, and the blanket is space-time itself. Now, if I were to take a grain of sand and place that into the center of my space-time blanket and it dipped down infinitely, that's what a black hole is, right? It's this infinite tunnel leading down to something, our little singularity. Now, there are about 4 different types of black holes of varying masses, but this one right here that we're seeing is a supermassive black hole. So supermassive black holes are pretty common, actually. We've seen one in every single spiral galaxy we've seen so far, and they're at the very center. And for some of you guys, you might be like, wait a second, but we're in a spiral galaxy, right? The Milky Way is a spiral galaxy. We do have a supermassive black hole here in the Milky Way galaxy. It's called Sagittarius A star, and it is at the very center of our galaxy. It's in a very stable, or it's got everything around it in a very stable orbit. And so it is not coming towards us anytime soon. Oh, and it looks like Sarah was pointing out where Sagittarius A star would be. That's the center of our galaxy right there in Sagittarius, which is why it's called Sagittarius A star, because it's in Sagittarius. But the importance of this picture right here is, first off, it was taken with a telescope the size of the Earth, which should raise some red flags, right? Like, how do we get a telescope the size of the Earth? Well, this is called the Event Horizon Telescope, and it's actually a series of multiple telescopes all across the Earth that looked up at the same part of the night sky and fed in a bunch of data. And that data went through an algorithm that was written by Katie Bowman. She put together this algorithm and made it to where we can actually see what those telescopes were seeing right here. So this is in radio frequency. So we talked earlier about spectroscopy. Radio frequency is one of the areas on this electromagnetic spectrum, right? This spectrum of any form that light could take. And so the importance of this just isn't just the fact that it is a black hole, or the fact that it was in a, or that, sorry, or the fact that it was taken by a telescope the size of the Earth. The huge thing about this right here is this was the first ever image of a black hole ever, and it was taken from 50 million light years away. Now, for those of you guys who aren't familiar with distances in space, we talk in terms of light years. And that's because you don't want to say something is a trillion, million, billion, gazillion miles away. Like, that just starts to lose meaning. And so we talk in terms of light years. Now, a light year is the distance that light will travel in a single year. And that distance is 6 trillion miles, which is a lot, right? Let's put it into context. If you were to start counting right now, one number per second, and you wanted to count to 1,000,000, no breaks, no breaths, nothing. You wanted to count to 1,000,000, it would take you about 11 days, which is totally possible, right? Just like chug a bunch of Red Bulls, count your face off, you could do that. But if you wanted to count to 1,000,000,000, it would take you about 35 years, which, if you factor in breaks and such, that's just that's more than a human lifetime, right? I mean, that would take your entire life, which, unless that's your literal life's goal, that's just so not worth it. But if you wanted to count to 1,000,000,000,000, keeping in mind that one light year is 6 trillion miles, a singular trillion would take you about 37,500 years to count to. That is longer than modern civilizations have existed, so not possible. So the fact that this picture was taken from 50 million light years away is mind-boggling, right? That's a crazy huge distance. Now, I could sit here and talk to you guys about black holes for literally the rest of the night, but I definitely shouldn't, because this is not a black hole stream. This is a penumbral lunar eclipse stream. So let's go ahead and check back in on the moon. So let's take a look at that moon cam there. Now, Danielle, are we starting to see any shadows on the surface of the moon quite yet? Let's take a look. Moon cam. And if we want to move the Malin cam over to the moon too, let's go ahead and do that as well. All right. So we're starting to see some nice images. It's difficult to say whether we are starting to see that shadow or not yet. We do still have a little bit of time before the peak, the maximum of the shadow comes through. So no worries, we'll hopefully be able to see something here soon. And as you can see here on the right, we have, we're about 45 minutes away from the max, I've just been told. So on the right, you can see that the Malin cam is currently looking at the moon, and you'll notice that there is, you can't really see a shadow on the moon from this view either. And we probably won't really be able to see the penumbral lunar eclipse on the Malin cam anyway, just because it's not really, it's not something that you would want more light for, right? The more more light it oh, sorry. The more light you take in, the less you're going to see all of those shadows coming across the moon. So once we want to start seeing the penumbral lunar eclipse, we're going to want to look at the moon cam instead of the Malin cam. But the Malin cam is showing us a fantastic view of the moon. I mean, look at all those beautiful craters. We've got those really bright highlands, all of those dark maria on the surface of the moon. I mean, this is just an absolutely gorgeous picture. And just for fun, I would like to show you guys something that I found out when I was looking at the moon a while ago. And it was completely by accident. I had been looking at a nebula, and so my contrast was up really high. And I moved over to the moon, and I was shocked. I had no idea what was going on. So if you want to turn the contrast all the way up, Sarah, let's take a look, and the saturation all the way up as well. You can see that the moon started to get almost like an orange tint to it. I don't know what it was. I think, yeah, maybe try. There we go. Yeah, it was something along those lines, right? My white balance was off a little bit. And so there it is. That's exactly what I saw. So I moved to the moon and I saw this and I was so confused. I was like, is this a lunar eclipse? What's going on? And I looked up at the sky and it was totally white. And so I was baffled. And then I looked over at all of my settings and I realized that we weren't seeing true color on the moon, right? So I had to white balance it and then it went back to being the normal moon. But you can see moving around those white balances, we can create some really cool colors on, oh, that was interesting. Brings a whole new meaning to the words blood moon, right? It's a blood red moon. Anyway, so oh, it looks like Sarah's gonna do some fun stuff with this picture she just took. Let's see, what are you trying to do? Just oh, inverted moon. That's you know what? Okay, that kind of looks like when you take an image of the inside of someone's eye, like the retinal areas and all of the veins and everything, doesn't it? That's crazy. Wow, I love seeing stuff like this where it kind of bridges the gap between different sciences, right? So you're looking at the moon in inverted color and you're thinking, wow, that looks like something like that looks like something you would see in a biology lab. Sarah would like to tell you guys that she likes how the craters pop in this picture, which is true. I mean, look at those. If you want to circle some of the brighter ones, or well, I guess they're darker in this case, but and then all those Maria are completely washed out because we're inverting the color. Yeah, switch back and forth between the video and the picture. Look at that. Look at those. Oh, I think that's so cool. Inverted color stuff is just so neat to me. So, as always, feel free to toss in some recommendations. Right, we want to know what you guys want to see instead of just messing around with colors on the moon. Even though that's super fun, I really like it. But Sarah, do you want to move it over? Let's see if we can get dumbbell now. Do you think it's dark enough to get dumbbell now? Let people know that I'm not crazy and it's actually there. Let's see. So this software that she keeps pulling up, that's how we're moving the plane wave telescope, right? You can see that you just click on the object you want to go to, and then it'll move it on over. So let's see, we're gonna wanna definitely up that exposure, switch from video mode to trigger mode, right? Because like I was saying earlier, you want less light when you're looking at brighter objects like the moon. So that's what video mode would be for. But then when it comes to nebulae and galaxies, we wanna be on that trigger mode so we can take in multiple seconds worth of light. You got to turn your gain up. Yeah, there you go. So that happens to me a lot. I'll have the gain all the way down and then I'll put it on something and I'm like, wow, why can't I see anything? And it's just the sensitivity was completely down. I couldn't see anything. So at the bottom, you can see that gray bar. That's the exposure bar moving up. I think you got to zoom out a little bit, maybe. Or is it zoomed all the way out? I see it off to the right there, I think. Pretty sure that's it. Oh, we also have to white balance. Remember that's why it's kind of bluer in the background there. That happened to us earlier when we were looking at the Ring Nebula. So let's see. Oh, there we go. All right, so the white balance is on. You can see it off to the far right. We're not sure why it's off, but it's there. She's gonna go ahead and try a star so that we can do something called a pointing model, so that we can get things centered in there, so that hopefully we'll be able to keep everything in the center from now on. Oh, that's a nice bright star. Which star is this? One of the brighter stars, Vega. Oh, so I love the star Vega. Vega is the brightest star in the constellation Lyra. And Vega is the second most studied star out there. The first one is, of course, the sun. And Vega is very popular in pop culture, specifically in the movie Contact, so or book as well. But in that movie, Jodie Foster, she travels to Vega. So if that name rung a bell and you were like, I wonder what's going on, that's what was actually happening there. Oh, there we go. Perfect. So that's the Dumbbell Nebula. Very nice. You can see why I would call it an apple core nebula instead. You can see that white dwarf star at the center. Very bright. Very nice. Yeah, pull up the saturation, pulling out those colors. It's really pretty. Let me actually, yeah. Oh, here we go. All right. That right there. That's our white dwarf star. Oh, I drew a little heart. Look at him. Anyway, so that's our little white dwarf star. Now, it looks like a lot of you guys are requesting planets, and we can get Jupiter now. So let's go ahead and move on over to Jupiter. Jupiter is the largest of our planets. It is significantly bigger than any other planet, especially Earth. It's got a storm on its surface that's about 3 times the diameter of the Earth. So it's a very, very large planet. And there you can see it right in there, a little orange guy. Let's see if we can make it look a little better. Ooh, you can see those stripes on there. Oh, that's nice. So Jupiter is the Roman version of the Greek god Zeus, and Zeus, he was known for having a lot of special friends. And so all of Jupiter's moons are named after friends of Zeus. And Jupiter has quite a few moons. You can see 3 of them in that picture right there. Oh, there's the 4th. So these are the 4 Galilean moons. Now, the Galilean moons, these guys are the biggest, brightest moons of Jupiter, and they were discovered by Galileo. So they were named after him. And we have Europa, Io, Callisto, and Ganymede. Ganymede is the largest, Io is the smallest. And the 2 that are right up next to each other, these guys are Europa and Io. Callisto is on the far right and Ganymede is on the far left. And you can pretty much tell in here. I mean, at least I think I can see that Ganymede is significantly brighter than the other ones, and it is the biggest of those 4 moons. And I always like seeing this because they're kind of in a nice little diagonal line across from where Jupiter is. So Jupiter has quite a few moons. I believe last time I checked, it was somewhere in the 80s, about 80 something moons. So there are planets out there with lots and lots of moons. Let's go ahead and try to zoom in on Jupiter. It looks like some people are wanting to see that. We'll have to down the exposure time. We were blowing it out so we could see those moons. And so the thing about the Malin cam is it's made to see kind of deeper space objects, right? We want to see things like nebulae and galaxies through this. It's not really meant to see planets. And so it is going to look a little different than what you would expect to see on a camera like this when it comes to planets. But planets are just so close and they're so bright. This takes in so much light, but you can see those stripes on there. I like to call them Jupiter's tan lines because I read somewhere that the whiter areas are whiter because they have a high concentration of zinc, and zinc is the active ingredient in sunscreen. So I like to say Jupiter forgot to put sunscreen on those darker areas. Of course, that's not how it works at all, but that's something that I like to talk about. Jupiter is a gas giant. It's mostly atmosphere, and it actually has multiple storm systems all across it that rage on for years. So the one I was talking about earlier when we first moved over, that's 3 times the diameter of the Earth. That's called the Great Red Spot. and that's the largest of Jupiter's storms. But there's a ton of other storms all across the surface of Jupiter. Some in the darker regions, some in the lighter regions. They're really interesting, and I highly encourage you guys to look at the pictures from the Juno mission. That was one of the missions that went straight to Jupiter and took some really beautiful pictures of it. And if you do look, personally, I think they look kind of like Picasso paintings. Pablo Picasso. He's one of my favorite artists, so I think it's pretty cool. Oh, also, I would like to tell you guys that Jupiter is at opposition on July 13th, a week from Monday, and Lowell will be doing a live stream that'll talk pretty in depth about what it means for a planet to be at opposition, and we'll have a live stream going of that as well. Our one of our astronomers, Dr. Jennifer Hanley, will be talking about Europa, one of Jupiter's moons that we were talking about earlier. If you want to zoom out and show us those moons again, real quick, Sarah. We'll be talking about Europa on, so we'll be talking about Europa. We'll also be talking about some history of E.C. Slifer, one of our old historical astronomers. He took a lot of images for Lowell Observatory, and so we'll be talking about planetary photography. That's kind of what he was known for. So Europa is one of the two that are right up next to each other. Cool. So let's go ahead. It's been a hot minute. Let's check in with our moon cam and take a look at what we're seeing there. So Danielle, does it look like we're seeing any any discernible shadow showing up? We're about half an hour out from the maximum, so we might be able to start seeing something. Let's take a look. And we'll move the Malin cam back over to the moon as well, get some nice pictures of it. So it looks like possibly we might be able to see a little bit of shadow. It's a little hard to tell still, but definitely keep an eye out for that. Like I said, just use your eyes and look up at the moon, and you'll be able to see this very slight shadow happening. You can even use binoculars. Binoculars would be a good one to view the penumbral lunar eclipse as well. And if you guys notice, the moon view on the Malin cam was a little oranges again because we had all of those settings for Jupiter on, and so once we moved over to the moon, it kind of looked a little oranger, right? So right about there, that's what we were seeing. I think it kind of looks like a sunset, which is pretty cool, seeing like a sunset on the backdrop of the moon. I think that's a funny one. But yeah, now let's check in with our chat. Have we got any requests yet? Because if not, I'll start talking. I mean, I'll talk all night long about the Apollo landing sites. There were quite a few Apollo landing sites. Apollo 11 we talked about earlier was at the Sea of Tranquility. Crazy story about that. So they were using the maps that were made here at Lowell Observatory by Patricia Bridges, Bob Malfair, and a couple other people. And they were using, these maps right here. And they had them with them while they were flying out to the moon, those 3 astronauts that were sent out there, right? And they looked down and they realized that they were going too fast, and they were actually going to overshoot the area that they had specifically picked, this very nice, very flat area where you wouldn't end up falling into a crater or anything like that. They saw that they were going to pass that if they didn't slow down. And so they actually had to take over manual control and land the craft before anything could happen. Because if they hadn't landed the craft, and there's a video of that, I highly recommend you guys checking it out. You can hear them talking to Houston, and Houston says 30 seconds. And what that means is there were 30 seconds before they ran out of fuel and they wouldn't be able to get off of the moon. It's incredible. I mean, just hearing that, I actually started crying because it was just insane, right? The fact that they were so close to missing their mark. So that was in the Sea of Tranquility. We also had Apollo 11, Apollo 14, 15, 16, and 17 all landed in various areas, most of them on those mare because that's where it's like flatter surfaces. So looks like I have some requests for Galaxy in the Virgo cluster. We have M85 up tonight, which is a galaxy with a supernova in it. So for those of you guys who were here at the beginning, I talked about type 1a supernovae and how those are used to determine distances in space. I don't believe these are type 1a supernovae, but they are still visible quite nicely. So as you can see, we're going to have to turn back on that trigger mode, start a longer exposure. And let's see if we can see these galaxies here. Oh, the gain was all the way down again. So again, gain, sensitivity, it's got to be up, not completely at 0 for us to see some stuff. So you can see that exposure bar down at the bottom, filling up 13 seconds worth of light coming in to show us this picture. Oh yeah. So that right there, that brighter part in the middle, do you want to hit white balance real quick so it's a little less blue? So that middle part, that would be the core of the galaxy. And then I don't know if it's just one of the dots there. It might, I'm pretty sure it's just one of them. That one right there. So that is the supernova. So supernovae, extremely violent occurrences, very bright, energetic things that happen. And so you can see that that supernova is about as bright, if not brighter, than some of those stars we're seeing out there in our own galaxy. Oh, that's a nice one. Look at that image. Beautiful. And I'm being told it's the supernova is brighter than the last interactive stargazing. So we're seeing it much brighter. And you can see it's even almost as bright as the core of that galaxy. I mean, definitely not as big, but quite bright object right there. And you can see there's kind of a reddish haze around the center there. And that reddish haze, that's actually due to how the universe is. Now, when I say that, what I mean is the universe is expanding. Now, this was actually first found here at Lowell Observatory by our second director, Dr. Vestal Melvin Slifer, who studied spectroscopy. So we've brought up spectroscopy a couple times tonight. It's taking something's light, and that light will tell you what that thing is made of, or in this case, how it's moving. And so what we're seeing right here is something called redshift. Now, redshift has to do with the Doppler effect. Now, the Doppler effect, if you've never heard of it, you've heard it. If a plane, a train, an automobile, something comes by you, and you hear that sound as it passes you, right? That higher pitch frequency as it comes towards you, that corresponds to all of those dark lines in those spectral actually, do you want to bring up the spectrum really quick so that people, there we go, so that people can see what I'm talking about. So those dark lines are actually physically shifted towards the blue end of the spectrum when something is moving towards you, and then they're shifted towards the red end of the spectrum when something's moving away from you. And so V.M. Slifer, our second director, he studied what were thought at the time to be nebulae, those clouds of gases and dust like the Ring and the Dumbbell Nebula that we saw earlier, but they actually turned out to be galaxies. And first he studied the Andromeda Galaxy. And so the Andromeda Galaxy was thought to be a nebula, and he saw that it was blue shifted. It was coming towards us. And then he calculated how fast it was going, and he saw it was going way too fast to exist in our own galaxy, which led him to believe that it was a galaxy of its own. And then he studied many other objects, starting with M104, the Sombrero Galaxy. So let's go ahead and look at Sombrero really quick, and then we'll hit some of your guys' requests. But Sombrero Galaxy, this is one of the most beautiful galaxies to see. And I'm being told that the autofocus for the moon cam is on the tree right now, so it will sharpen up in just a minute here. Oh, beautiful. Okay, so we can see here that the Sombrero Galaxy, oh, nice and bright. Wow. So Sombrero Galaxy is what's called an edge-on galaxy. So an edge-on galaxy is different than a face-on galaxy. So a face-on galaxy would be like this, whereas an edge-on goes like this. And so what you're seeing there, or it's about tilted like this guy right here, what you're seeing is in the middle of this galaxy right here, right? This is called a dust lane. So this part right here, this dust lane, that is a darker spot, darker region, all of those nice heavy dusts, right? Metals and such. Oh, I forgot to take it off. heavy metals and such. And this was the first galaxy that Vestos Slipher studied the redshift on. So this was the first galaxy that he saw the redshift, and then he saw many other galaxies that had this redshift, and that led him to the conclusion that the universe is expanding, or well, he presented his findings, and then Edwin Hubble actually took all of that information and came up with a theory of the expanding universe and proved it. So that's why we're seeing some redder tints to a lot of these things. All right, so let's check out some of our requests. So it looks like AZ Weaver would like to see Antares. So Antares we looked at earlier tonight. It's going to be that really nice red star. And this is a very old cold star that started off its life about the same size as our sun. And now it's about 30 times our sun's diameter. So you can see it right in there. Some really nice red tints to it around it. We're going to do a long exposure so that we can see some, oh, look at that, some diffraction spikes. Those are beautiful. Oh my goodness. So this is just something that happens when you take in so much light, it starts to kind of refract off. And I think this is really cool because a lot of times you see stars depicted as like the 4 lines with the dot in the middle. And so with this, it actually looks like those stars that people draw sometimes. So I really enjoy this picture right here. Great question, or great request. All right, let's see. Hannah Zygo, hello, one of my coworkers. She wants to see the Whirlpool Galaxy. So Whirlpool Galaxy is another really beautiful galaxy. This one is beautiful because you can see some really nice spirals in it, right? So it looks like a whirlpool. And the Whirlpool Galaxy is a galactic merger in progress. So earlier we talked about how galaxies can collide. We talked about how M13, the Hercules cluster, might have been the core of a galaxy that the Milky Way consumed. And so this right here is an active galactic collision. So we can see those 2 brighter kind of reddish spots in there. Those are the cores of the 2 galaxies. And the one on the top is significantly bigger than the one on bottom. And so it's actually pulling all of those gases off of all of that dust off of that galaxy right there. And they're going to combine into a single galaxy. So we're taking a little bit more light so that we can get a clearer image. Oh, wow. There are some images out there that just take my breath away. And this is one of them. I mean, just look at that. I mean, all of that contrast, the really bright spirals with those dust lanes inside of it. I mean, Whirlpool is beautiful, beautiful galaxy. I think one of my favorites to view for sure. Nice request, Hannah. So we have another request for a supernova. So why don't we go ahead and look at M61? That's the other galaxy that's got a supernova in it right now. Another galaxy in the Virgo cluster. Just a side note. So all of these images, I mean, they are beautiful images, but I mean, you don't have to believe me on this, but they get better, right? They can be so much better when the moon isn't up, because the moon's light actually interferes with all of these different images, right? It's kind of blurring out all of the really nice contrast that we can get most of the time. But I mean, even now with the moon up, a lot of these images are just fantastic to look at. All right, so this guy right here, this is M61, and M61 is another galaxy that currently has a supernova in it. It's that one right there that Sarah's pointing to. Look at that guy. So it's a little less bright than the other supernova was, but definitely still quite bright for being in a galaxy that's tens of millions of light years away. So I think that's pretty fantastic. Now, all right, let's see what else have we got going on. So before we continue on with your guys' request, let's actually, for those of you guys who are just joining us or haven't heard it yet, let's go ahead and take a look at our penumbral lunar eclipse PowerPoint that I put together. So we've got little slide on types of lunar eclipses. So we have our total lunar eclipses, our partial lunar eclipses, and our penumbral lunar eclipses. So tonight we're going to be seeing a penumbral lunar eclipse, and you can see there's a picture down there at the bottom. On the right, we have our penumbral lunar eclipse. And so what we're seeing right here is not nearly as dramatic as a total lunar eclipse would be, right? With a total lunar eclipse, it's got that reddish tint to it. But with a penumbral lunar eclipse, if we go to our next slide, you can see that the moon isn't passing through the Earth's umbra. So the umbra is that darker shadow that we're seeing in there, and then there's that outer shadow, the penumbra. And so for a penumbral lunar eclipse, the moon is just passing right through that penumbra. And so it'll be maybe about 33% darker than it normally is. So it's definitely one of the harder eclipses to look at, but it's definitely worth it. If we go to our next slide, you can see how to view a penumbral lunar eclipse. Super easy, anyone can do it. Just find a clear view of the moon and sky. Usually if you go a little bit outside of town, that's the best because there's the least light pollution. You want to dress for the weather. So like I've been saying here in Flagstaff, even though it is summer, it still gets kind of chilly at night. So definitely put on some layers or even bring a cozy blanket. And you want to find a comfy chair, or you could even do a hammock, right? Hammocks are really fun. I mean, if you want to get super creative, you can get one of those bounce houses that have no top to them, so you can bounce around and like lay down and look up at the sky, and then just know what to look for. So like I said, it's going to be just a little bit darker than it normally is, and that's going to be our penumbral lunar eclipse. Now let's go ahead and move over to the moon cam. Danielle, does it look like we're starting to see a little bit of a shadow? We're about 15 minutes from the max eclipse, so we'll definitely put it on there once we're at the maximum. So let's see, we've got, it'll be kind of top left of there. We're not quite, we're kind of seeing a little bit of a shadow there. So it's pretty nice. But yeah, all right. So let's go ahead and go back to our Malin cam so that we can see some nice images. Oh, we've got the moon on right now. That really funny color that we're seeing lately. We got the white balance so that we can see the darker areas, those Maria, and then the lighter areas, those craters and the highlands on there. All right. So let's go back to our requests. It looks like Joe Richards would like to see M4. Is M4 in our field of view, Sarah? Let's see. And like I said, this is the software that moves around the plane wave. That's the telescope that's got our Malin cam camera attached to it. And so Sarah's just going to, it's called slew. She's slewing over to M4 from the moon. And we're going to go ahead and turn on trigger mode. We're going to take in a couple seconds worth of exposure here, turn up that gain so that we can actually see something. And let's see. Oh yeah, okay, that's really nice. Maybe take a little bit of longer exposure so we can get some of those dimmer stars out too. All right, let's see. So at the bottom, you can see our exposure bar. It's filling up all the way to, it looks like right now we're taking a 10-second exposure. Oh, wow. That's beautiful. That's gorgeous. So this is a globular star cluster. This is a couple 100,000 stars that are at the outer edge of our galaxy. Very beautiful red stars, right? These are older, colder stars. These are actually some of the oldest stars in our galaxy. It's pretty great. Yeah, that great idea. Thank you, Joe Richards. That's a beautiful picture. All right, so next up, Hannah Zygo, hello again. She would like to see the Whale Galaxy. So let's go ahead and look at the Whale Galaxy. The Whale Galaxy has a pup, which Sarah will point out when we get to it. So you can see, the reason we have these weird letters and numbers at the beginning of things, we have M13, M whatever, or NGC, and then a bunch of numbers. Those are different catalogs. So the Messier catalog, that is a catalog of some of the brighter, kind of really fantastic views to see that way back when Charles Messier was looking for comets, they looked a lot like comets, and so he was getting sick and tired of seeing these things that weren't actually comets, and so he started making this catalog, and they turned out to be some of the most beautiful objects to view in the night sky. NGC catalog is a little bit of a newer catalog. It's got a lot of objects in it. I mean, there's thousands of objects in the NGC catalog, and Whale Galaxy is one of them. So you can see this guy right here. Oh, it's really pretty. It's kind of faint. We're getting in a little bit more of an exposure, but you can see there is, oh, wow. There is like a dust lane in there. We've got its little pup. Sarah, if you want to circle that little pup right there. Satellite galaxy, I'm assuming. Satellite galaxies are smaller galaxies that orbit around bigger galaxies, or even kind of almost in galaxies. And actually, our Milky Way galaxy has two satellite galaxies, the Large and Small Magellanic Clouds. Those are the biggest ones. I think it's got a couple more, but this one's really nice and pretty. Now, I've been told to remind you guys that this eclipse tonight, the penumbral lunar eclipse, will be subtle. So definitely really remind yourself of that. It's not going to be like a total lunar eclipse where it's going to be super bright red or anything. It's just going to be about 33% darker. So definitely check that out. We're coming up on the max right now, so keep an eye out for that. All right, now it looks like Hannah Zygo would like to see Bode's Galaxy. Ooh, okay, so Bode's Galaxy, I really like this one. I actually prefer its partner galaxy, Cigar Galaxy, which we'll look at next, but Bode's Galaxy is a face-on galaxy. So like I was saying earlier, face-on is like this and edge-on is like this. And so Whale would be an edge-on. Oh, wow. I'm assuming we might be in either the dome or a cloud. Roof. All right. So with the plane wave telescope, it is possible to flip around and actually be looking into the roof of the Giovanni Open Deck Observatory. So it looks like we will not be able to get Bode's Galaxy, which means we probably also won't be able to get Cigar Galaxy. Both are really pretty objects, so definitely check those guys out. And it looks like we're about 7 minutes out to Saturn, maybe a little bit more. So we'll take a look at that a little bit later for those of you guys who would like to see it. I have gotten a request for the Eagle Nebula with the pillars. So since the moon is so bright, it is going to be a little bit harder to view this one. So we're going to look at the live stream, but we also have a famous picture of the Eagle Nebula that we'll show you guys once we're up there. Let's see. There we go. Oh, beautiful. So that picture, that is the Hubble Space Telescope picture of the Eagle Nebula. This is Eagle Nebula with pillars, and that is because those are called the pillars of creation. Now, the reason they're called that is because this is an active stellar forming region. So those dusts in there, they are actually birthing stars as we speak, which is, I mean, pretty fantastic if you ask me. Eagle Nebula is definitely one of my favorite things to look at in the night sky. So hopefully we'll be able to see at least a little bit of it. Since the moon is so bright, Eagle Nebula is a pretty faint object. So it might be a little bit dimmer. It's definitely not going to look like the picture we just showed you guys, but you'll get the gist of what it's actually supposed to look like. Let's see. All right, so you can see it a little bit in there, right? That area that Sarah's zooming in on. And this is, I mean, yeah, you can kind of see it. Maybe, yeah, mess with the exposures a little bit, contrast, yeah. So a lot of doing the Malencam, a lot of taking these exposures and such, it's kind of like a guessing game, right? You have to mess with stuff, and then you actually have to like stop the whole exposure to mess with some of the things. Some of the things just won't take place until the exposure's over. Oh, you can see it kind of in there, right? You can see some little gas areas right in there. Yeah. Yeah, that's awesome. So this is called a stellar nursery, actually, because it's where baby stars are born. So I really like that because it's like a baby nursery, but for stars. And just know that when I say baby stars, I don't necessarily mean they're like a couple years old. Baby stars can be millions of years old, right? Some stars have very, very long life cycles. So these can be born just now or a million or so years ago, which is pretty cool if you ask me. All right. What have we got next? So yeah, about oh, actually, we can go to Saturn now. So let's go ahead and take a look at Saturn. Saturn is, of course, known for its rings, and the universe. It actually it took Beyonce's advice and it put a ring on it, right? Because it's so beautiful. That's one of my worst dad jokes. So just so you guys know. All right, there we go. So again, we can see that wobbling, that atmospheric distortion. Saturn is very low on the horizon, and the lower something is on the horizon, the more atmosphere we have to look through, and so the wobble is going to be quite a bit worse when it comes to Saturn rather than something that's straight up above us. But you can still see the rings of Saturn right there. You can see the little gaps on the sides. Fun fact, Galileo, he studied Saturn, and he didn't, no one really knew about rings around planets. And so he said it looked like Saturn had ears because it's got those little bulges on the sides. So I think that's pretty funny. So we're going to blow out Saturn really quick so that we can see the moons. So you can't really see anything on Saturn, but you can start to see those moons. Oh, there we go. So that super bright one right there, that is going to be Titan. So Titan is the largest of Saturn's moons. Titan has an atmosphere, which is pretty crazy, right? Moons don't typically have atmospheres. On Titan, it actually rains, snows, there's lakes and rivers. Titan is the only other place in the solar system that we find a convective system like here on Earth. So it's a pretty fantastic moon. The only difference is it's actually methane based. Titan is methane based, which is kind of interesting. It looks like the one on the far left is probably Enceladus, I'm guessing. Enceladus is another one of Saturn's moons. It's actually an ice moon. And so it's got this water ice crust and liquid water interior. So Enceladus is one of the candidates for life off of Earth. Now, when I say life off of Earth, I of course mean bacterial life, not necessarily like mermaids, even though I would totally love to find a planet full of mermaids, but I mean, that's just me. All right. Oh yeah, nice and pretty. Saturn actually is about twice as far from us as Jupiter is, which is pretty crazy because we can see it very clearly, especially the rings. And it's interesting that we can see the rings so clearly because they're extremely thin. But Saturn's rings are primarily ice, and ice is one of the most reflective one of the most reflective things out there. And so it's reflecting back almost all of the light that's coming onto it. And just for to compare, let's go ahead and look back at Jupiter so that you can see the difference between the two. And in about 4 minutes, we're going to hit our max eclipse. So we'll head over to the moon cam once we're done with this. But you can see here, we've got it blown out because we were looking at the moons. But if we down the exposure time, a little bit lower, there we go. Beautiful. You can see those stripes on Jupiter, really nice. So there's a difference between stripes and rings. Stripes are on the surface of the planet. So these are actually winds on the surface of Jupiter. And by surface, I mean in the atmosphere of Jupiter because Jupiter doesn't really have a surface. And then rings are around the planet. And so Jupiter actually does have a ring system. It's just very thin and rocky. And so it's significantly harder to see than Saturn's because, like I said, Saturn's rings are primarily ice, which are extremely reflective. All right, so before we get to the maximum eclipse, I would like to go back to those slides that we've got on what a penumbral lunar eclipse is so that you guys know what to look for. So if we go back, we've got our types of lunar eclipses: total lunar eclipse, partial lunar eclipse, and penumbral lunar eclipse. So we see those pictures down at the bottom of the slide there are total, partial, and penumbral. So the penumbral lunar eclipse is, of course, what's happening tonight. It is in progress right now. The max is in about 3 minutes. And what you're seeing here is a very faint shadow passing over the surface of the moon. So it's about 35% of lunar eclipses are penumbral lunar eclipses. The moon will be about 33% darker than it normally is. And if we go to our next slide, you can see what a penumbral lunar eclipse actually looks like from space. We have the sun on the far left shining light onto the Earth. The Earth has two shadows. That inner cone is the umbra, that's the darker part of the shadow. And then the outer part is the penumbra, which is that lighter shadow. So as you can see, for the penumbral lunar eclipse, the moon is partially in that penumbra right there. And of course, for you guys who are just tuning in, if you want to view the lunar eclipse, it is very easy. You just go outside, you look up at the sky, find a clear view of the moon in the sky. Keep an eye out for just that subtle little shadow coming across from it. You want to dress for the weather, so that might be a t-shirt and shorts. It might be a parka, depending on where you are. And then you want to find a comfy chair, or you can even find a hammock. I mean, if you really want to, you could just lay on the ground in a grass field. I don't know, whatever you're most comfortable with. And then you want to know what to look for. So like I said, you want it to be a little bit, you're looking for it to be a little bit darker, about 33% darker. So let's look at our moon cam. Our max eclipse is happening right now. So on that moon cam, Danielle, are you seeing a little bit of that shadow there? Let's see. It's a bit dimmer in the upper left. Yeah, so that is the max penumbral lunar eclipse. So congrats, guys. I was told in the chat earlier that this is the first eclipse that's happened on July 4th in the United States. So I don't know if that's true, but I mean, I believe it. I believe it. So way to go, guys. Welcome to lunar eclipses. Definitely keep an eye out for more lunar eclipses that will take place pretty soon. But yeah, very pretty little shadow on the upper left of the moon. So make sure you're looking in the upper left of the moon. Let's go ahead and move over to the Malin cam, where we've got a really nice good view of the moon. And like I said, on the Malin cam, you can't really see much of a shadow on there. I mean, a little bit, but definitely more so with the moon cam or just with your eye. You can see it a little bit better. But yeah, awesome. Well, that was the max eclipse, and it looks like we've got a couple more suggestions for objects. And we were actually hoping someone would ask for this, so let's look at Pluto. Now, the thing about Pluto is it is extremely small. I mean, super, super duper small. And so we're going to be looking at something that looks like a wide field view of just a bunch of stars. And one of those tiny little specks is Pluto. So you're not really going to be able to tell which one it is, but we do have some pictures that will show to explain how we at Lowell Observatory found Pluto. And by we, I definitely don't mean me. Oh, whoa, what is happening there? Let's see, tree? We might be in a tree. We're not entirely sure. Or moon. Huh. Let's down the exposure and see what happens here. But yeah. That's weird. I've never seen that before. I don't know. Let's try to refresh it and see what happens. Yeah, no, that's interesting. We must be looking through a tree or at the moon or something. But anyway, let's go ahead and pull up those pictures we've taken of Pluto. So what we have here, like I said, wide star field, and one of these little teeny tiny dots is Pluto. And so the way Clyde Tombaugh found Pluto was actually by taking pictures like this and comparing them. He compared them in something called a blink comparator. So a blink comparator takes in two big glass plate photos like this and blinks back and forth between the two of them to see if anything moved. So I want you guys to look at this. We'll blink back and forth a couple times. See if you can find the one thing that jumps a little bit. Oh, I think I found it. All right, are you ready? Sarah, will you reveal where Pluto is? Let's see. There he is. Perfect. So you see that middle star right there moving back and forth. That is not a star, that is Pluto. So that's how Clyde Tombaugh found Pluto. He was 24 years old, which is amazing to me. I think he's like the coolest person in the world, honestly. Clyde Tombaugh's story is amazing. But he actually searched for 9 months, took 200 plates total, so 100 pairs of plates. He would take one picture, and then a couple days later, he would take the exact same picture so that you could compare the two of them to see what had moved. And after 9 months, he finally found Pluto with these two plates right here. So it was a really fantastic time. I mean, that was the first time a planet had been discovered in the US. And oh, and so I'm being told these pictures right here were taken with the 17, the plane wave that we're using right now, last September. So basically, you take a picture, a couple days later, you take the same picture because over that time, stars don't move, but planets do. Oh, it looks like Sarah's got a nice picture of the moon up for us again. So, like I said earlier, we've got those darker regions. Those are the Maria, the part of the moon that people thought were oceans. And then we've got those lighter areas, those highlands. They are the oldest parts of the moon, untouched by lava flows and untouched by most craters. Now, do you guys have any last minute requests? It looks like we're about to wrap up here, but if anyone has any more objects they would like to see, speak now or forever hold your peace. I'll wait a couple of minutes. I'll talk about the moon a little bit more until I know for sure. But yeah, the moon's pretty fantastic. I mean, it is well, it's the reason we have tides, first off. So if you like surfing, then you can directly thank the moon for that. And the moon is actually, before we get into it, the moon is actually tidally locked to us. So what does tidally locked mean? Well, that means that the moon rotates, but it takes 365 days to make one rotation. So it's tidally locked as in the Earth is rotating here, the moon is rotating around like this. And so Earth always sees the same face of the moon, this face right here. So if there's a half moon or something and you see that darker part and you think, oh, that's the dark side of the moon, it's actually not. The dark side of the moon is the back side of the moon that we will never be able to see from here on Earth. Now it looks like we've got a final request for M5. So let's go ahead and take a look at M5. Final object for the night. Let's see. So, like I said, this is the software that we're using to move around the plane wave. The plane waves move ridiculously fast for telescopes, and they're dead quiet. So we call them the ninja telescopes because it's insane. They go from one side of the night sky to the other in like a second. It's crazy, and they're so quiet compared to a lot of telescopes out there. So your gain is all the way down, Sarah, if you want to pull that up. There we go. All right, let's see. Take that exposure. Let's see. M5. I'm pretty sure, is M5 the rose cluster? I think it is. M5 is another globular star cluster, so we can see it in here. If we pull up the exposure time a little bit more, this is one of the fainter ones, but it is very clear. It's got some very sharp stars inside of it, which I think is really cool. So if we take this longer exposure, there we go. So you can see that core in there quite a bit. We're even going to up the exposure a little bit more. Maybe do a white balance because we're seeing it kind of blue right now, but it is actually red. We should be seeing some red in there, not the blue. And it'll take until the end of the exposure to correct everything. There we go. Oh, wow, that's beautiful. We got that nice condensed core, very orange areas in there. Wow. I think this is the perfect object to wrap this up, right, guys? I mean, this is beautiful, and this is as good as it gets right now. So, beautiful images. Thank you guys so much for hanging out with us tonight. Definitely keep looking at that penumbral lunar eclipse. It ends at about 10:45 or so here in Flagstaff time. So, definitely check that out. And don't forget that on July 13th, we'll be doing a live stream of Jupiter at opposition. So that's going to be a really fun one as well. Feel free to tune in and join us for that, where we'll talk a little bit more about what an opposition is and what it's going to look like. And we'll do a live stream very similar to this one. So thank you guys so much for hanging out with us. Like I said, my name's Haley, and I'm glad you guys came to the live stream. Thanks.